All right, so we're going to work two more examples here of graphing our rational function. So starting with number 4, remember step 1 is to simplify the function. So looking in my top, I can't simplify it, but in the bottom, I have a trinomial, and I can simplify this by double parentheses. So luckily I don't have a coefficient in the front, so I know it's just going to be x and x. And so I have 20 on the outside and 9 in the middle. So I want factors of 20 that add to 9. Well, that would be 4 and 5. So I'm going to have plus 4 and plus 5. Now, notice that I have an x plus 5 in the top and an x plus 5 in the bottom. So those can cancel, and my simplified function is now going to be 1 over x plus 4. So that was our step 1 here. We simplified the function. Now remember, step 2 is to find the x-intercept by setting my numerator equal to 0. Well, my numerator here is 1. If I set 1 to 0, does anything happen? No. So that means I don't have an x-intercept for this problem. No x-intercept. All right, moving on to step 3, we find the vertical asymptote by setting the denominator equal to 0. So my denominator is x plus 4, and if I set that equal to 0, move the 4 over, I get x equals negative 4. So my vertical asymptote is x equals negative 4, and I'm going to plot that. 1, 2, 3, 4. Here we go. It's the same as that last example we worked. Okay, so step 3, done. Step 4, horizontal asymptote. Remember, that's by our biggest exponent in the top and the bottom. Well, I don't have an exponent in the top, and I have an exponent of 1 in the bottom, which means my exponent in the bottom is bigger than what's in the top. And when that's the case, when the degree of p is smaller than the degree of q, that means it's at y equals 0. That's my horizontal asymptote. So I'm going to go ahead and draw that one in on the graph too. All right, step 5, identify any holes. So remember, a hole happens when I have a common factor in the numerator and the denominator. And I did have a common factor. I had that x plus 5 in the top and the bottom. So I find the x coordinate by setting the common factor equal to 0. So our common factor was x plus 5. And when I set that equal to 0, I get that x equals negative 5. So that's my x value. Then I find the y value by putting that into my simplified function. Remember, the simplified function is 1 over x plus 4. So I'm going to plug in negative 5 for x, and I'm going to get 1 over negative 1, which is negative 1. So that's my y value. So I have a hole at negative 5, negative 1. So I'm going to find that point, negative 5, negative 1, and draw a little hole. I have a hole in my graph right there. Okay? So, lastly, I just draw my graph. Oops. That was a little too close to the edge there. I want to make that a little neater. Okay. And again, you could check yourself with Desmos if you're not sure how to proceed from here, but roughly that's what your graph is going to look like. So domain, remember our x values. X cannot exist at negative 4 because that's where our vertical asymptote is. And our range, y, cannot exist at 2. Sorry, no, at 0 because that's our horizontal asymptote. Okay, so I have my domain and my range. That concludes number 4. All right, let's move on to number 5. Remember, step 1 is to simplify. So I have a trinomial in the top and the bottom, which means I can double parentheses both of them. All right, now, unfortunately, I do have a coefficient in the front here, but it's 2, which is a prime number, so I know I'm going to have 2x and x. And then I have negative 1. So the only real variable here is positive and negative 1. So if I test it out here and I FOIL, I'm going to get plus 1x minus 2x, and that is going to give me the minus 1 in the middle that I need. And then in the bottom, I don't have a leading coefficient, So I just need factors of negative 12 that add to negative 1, and that would be minus 4 and plus 3. Now, I've factored these, but they don't have any factors in common, so nothing is going to cancel. So really, I'm not going to be able to simplify here, okay? So let's move on to step 2. Step 2 is finding the x-intercept by putting the numerator equal to 0. So I need to set my top equal to 0. So 2x plus 1, x minus 1 is equal to 0. Now remember, because these are being multiplied by each other, if either of what was inside the parentheses was equal to 0, the whole thing would become 0. So I'm going to find my intercepts by setting each parentheses equal to 0 and solving. So I move my 1 over and I divide by 2 and I get that x is equal to minus 1/2. And on the other one, I get that x is equal to 1. So I'm actually going to have two x-intercepts. I'm going to have one at negative 1/2, 0, and at 1, 0. So that was step 2. Step 3, and I'm running out of room here, so I'm going to erase some stuff. Step 3 is finding our vertical asymptote, and we find that by setting the denominator equal to 0. And again, I have a double parentheses here. So when I set my denominator equal to 0, x minus 4, x plus 3, I have to again set each parentheses equal to 0. So x minus 4 equals 0 and x plus 3 equals 0. So that's going to give me x equals 4 and x equals negative 3. So I have two vertical asymptotes here. So I'm going to go back now and I'm going to graph both of my intercepts, and I'm going to also graph my asymptotes. Okay, moving on. Step 4, horizontal asymptote. Remember, I need to look at my greatest exponent in the top and the bottom. So for this problem, I have x squared in the top and the bottom, which means they have the same degree. I have a degree of 2 and 2. So my rule for that is I divide their coefficients. So my coefficient in the top is 2 and my coefficient in the bottom is 1. So my horizontal asymptote is going to be at 2 divided by 1, which is 2. So my horizontal asymptote is at y equals 2. All right. Whole. Remember, a whole only exists when the top and the bottom share a common factor, and this one didn't, so I don't have a whole. Okay. So now I'm going to go ahead and draw in my graph, and you can plot this into Desmos to see what it's going to look like more closely. And again, this is a very rough sketch. I'm not an artist, and on the computer, it's a lot harder to draw. Okay, so domain, all my x values. X is restricted at negative 3 and at positive 4. So x cannot be negative 3, and x cannot be positive 4. And my range, my y value is restricted at 2. So y cannot equal 2. All right, and that will take care of example 5.